Hello. How is everyone today?
Morning. Just
Morning.
just heading into the lab.
Oh, good. Yeah. Is that Kavya? Hello.
Hi,
Hi. How are you?
great.
Good. All right. So why don't we get started? So this week we had actually 3 meetings that we did. The first was DevoWorm. That was on Monday. Then we did our Cognition Futures meeting. That was on Wednesday. And then we did a open source meeting on Friday. So it was a very busy week for meetings. We're also talking about doing a lot of revamping of different resources. So Jesse's been working on his website revamp for JoePro. And, we're in the process, we're kind of revisiting a lot of things. So on Monday, we started with the DevoWorm meeting. Ashi Rajput and myself were there to begin. And then we got Barshan Mandal online. And we started talking a little bit about Barshan's pull request to DevoGraph. So this is where he added his epic preprocessing and dataset script. So this is the work he did for his weekly, I think it was week 2 of the coding period. So he has a number of different CSV files and a data loader that he was working on. So he uploaded all of that and issued a pull request, and it was accepted. So we reviewed that. Then we talked a little bit about Barshan's post on his experience for coding period, the second coding period week of GSOC. And he's keeping a blog where he's keeping a weekly sort of report of his experiences. And then he's going to post to the lab medium a couple of posts. He posted an introductory post. He's going to post a midterm post and then a final report. So that's all kind of forthcoming. All right, so yeah, and then he presented on all this. And then I got into this, I did 2 papers for the rest of the meeting. The first paper was this Ambitions for Theory in the Physics of Life. This is by Willem Bialik, who's a very famous and accomplished or theoretical biologist, a biophysicist. So he's doing a lot of things with biophysics and theory in biology. And so this was from a summer school where he delivered a talk on the role of theory in biology, where, in a summer school, you're typically, it's an intensive, maybe 2 or 3 week period where people get to do things in a wet lab, and then they have to reflect on those things by reading papers. And of course, this also had kind of a theoretical component. So how do you build theory from the experiments you're doing? And so that's what this was about. And he really kind of focused, the reason I like this article is because he focused in on the complexity of biology, and that being sort of the basis for theory. So when you observe something in the lab, you can develop a theory for it. You have to think about the complexity of that thing, and what is the right level to pitch a theory. I mean, what does it need to include? How inclusive does it need to be, etc. So we went through this article and spent a lot of time talking about different things in the article. Talking about going from, say, an experiment to a conceptual model, to maybe a set of equations, and then thinking about how your theory generalizes. So you might develop a theory of morphogenesis that largely focuses on Drosophila, or you might develop a theory of development that focuses on all different types of organisms. And it's going to be different. So this is one example where we have two components that we've boiled our experimental system down to, and the question is, does your theory include enough detail to be predictive? Sometimes you don't know enough about your system to develop a predictive theory. Other times you have enough and your theory is elegant. You want your theory to be simple, but you don't want it to be too simple. And you want to capture complexity without really kind of getting lost in that complexity. Yeah, so this is like an example from gap genes and Drosophila, and he gives an example of how you take things from a graph. So you have experimental data, you take things from a graph, and you build a conceptual model, and then you refine that model, and then that's the thing that predicts something. And so you can build a predictive model out of that. I think there was also an interesting correspondence here between the role of parameters in complexity theory and the role of parameters in neural networks. And we talked about this a little bit, but something that was interesting from this, because we think about sort of in machine learning and in deep learning especially, that we use a large number of parameters to describe a network. We can tune those parameters and get a predictive model. So what are we doing there? Well, we're kind of building a theory. We're building a theory of sort of data or of the data that we're analyzing. And so as we tune those parameters, we describe it with a large number of parameters. So in a sense, our theory is maybe, is it overfitting or underfitting what we're trying to understand? And so we can run into cases where our model overfits the phenomena or a model underfits the phenomenon. And the same holds true for theories. We can have theories that sort of overfit what we're trying to explain and some that underfit what we're trying to explain. So this is kind of I guess maybe the best way to put it is it's a correspondence between the two domains, but we don't really know why, what the actual connection is. So he also gives these different axioms for reacting to complexity. So the first is give up, life is really is that complicated. The second is we should study theories that remind us of the real thing, not try for quantitative comparisons of theory with experiments. Then 3 is the only real theory is how things are related to one another. 3 is we are interested in relatively macroscopic behaviors, which are usually more universal than microscopic mechanisms, and he brings up the renormalization group. Number 4 is the fact that living systems function often quite well and can be promoted to a principle that selects parameters or behaviors circumventing details. This is sort of the tie-in to deep learning. Okay, yeah, there was a little, okay, I stopped there. That was basically it. So he gave these 6 points and we reflected on it a little bit. Okay, then the next paper was this paper, Hyperagents. And this was kind of it was interesting that it was, is sort of tangential to the last paper, but it actually did fit in somewhat with what we were talking about. Because hyperagents are this sort of model of self-improvement of software agents. And there's this link to what's going on in intelligent living systems. And so it was interesting to read this after the other paper because it kind of tied things together in a unique way. So basically what they're interested in are these self-improving AI systems which aim to reduce reliance on human engineering by learning to improve their own learning and problem-solving processes. So this is what we call continual self-improvement, and we talked about Sakana AI in this group last time. And, they're doing this sort of thing where they're doing continual self-improvement. And so it is related to this because I think some of the people were kind of, sort of in collaboration with Sakana AI. I'm not sure any of the people are actually from Sakana AI, but there's definitely that connection there. And so one of the things we're interested in here is we're interested in these meta-level mechanisms that sort of limit or sort of put a cap on how much systems can improve in their accuracy. So we don't want to self-improve things too much and then not be accurate about them. But we also don't want to have to handcraft these meta-level mechanisms. And a lot of times when we, say we want to build a meta-learning system, we'll often just hand code it and that'll be that. But we actually want to have a system that's sort of self-organizing and can evolve on its own, but also do so in a way that's accurate. So to preface hyperagents, they mention the Darwin-Gödel machine, which is this paper from 2025. It was, I think, from the same author, that demonstrates open-ended self-improvement, which is achievable in coding. So starting from a single coding agent, the Darwin-Gödel machine repeatedly generates and evaluates self-modified variants, forming a growing archive of stepping stones for future improvement. Because both evaluation and self-modification are coding tasks, gains in coding ability can translate into gains in self-improvement ability. So they use this coding task benchmark in the Darwin-Gödel machine. And then in this paper, they introduce this idea of hyperagents because they want to go beyond the coding domain to look at task transfer and other things. So they find with the hyperagents example that these agents are self-referential. They integrate a task agent and a meta agent, so they have two agents that are doing things. And this means they don't have to hard code a meta solution. They also don't have to supervise it necessarily because it's a separate but related agent. So this means that the meta-level modification procedure is editable itself, enabling metacognitive self-modification, improving not only task-solving behavior, but also the mechanism that generates future improvements. And so they extend the Darwin-Gödel machine method to create this Darwin-Gödel machine hyperagents approach. And so this is where they're able to eliminate the assumption of domain-specific alignment between task performance and self-modification skill. It could potentially support self-accelerating progress on any computable task. And so they actually go across different skill domains. So they go beyond coding to go to paper review, robotics reward design, and math solution grading, and look at performance there. So this is an improvement on performance of other types of agents, showing that, this approach is fruitful. And so we went through the paper a little bit, and then that was the meeting. So we did have a little bit of meta learning in there in DevoWorm, but I think it does tie into theory building because, for two reasons. One is that metacognition is really about building theories. In some cases, a theory of mind, in other cases, a theory of the world. And so, this is kind of a route to world models, of course, but, it's interesting from the standpoint of building theories of things. And then the other way is that it kind of also talks about that parameter problem. And so how do we model very large amounts of data? How do we do that effectively? Okay, so then we had our open source meeting. So we did have our Cognition Futures meeting Wednesday, and Jesse can talk a little bit about that if he would like. But I want to go through the open source meeting, which Jesse also pointed to in the Slack. We had a very good discussion at the end of that meeting that Jesse led. That was really interesting. But we'll talk about that in a little bit. So the open source meeting was on Friday. We started by getting into Marshan's update. And so he talked a little bit about his work for this week, week 3. He talked about his, last week he issued a pull request that was a data loader and some files. This time he's working on this attention model that he's trying to implement and some of the components of that. So he's working on this edge attention aggregation model where he's looking at incorporating attention into a network itself. And then he has these 2 methods called dynamic relation learning and dynamic node learning, where this selects the nodes that need to be updated for future graph topologies. And so he's working on getting all this together and running. He's going to issue a pull request, I think, this weekend sometime. And so this is basically his work for the week. It's very impressive. I think he did a lot of work in a very short period of time. So we discussed a little bit about some of the things he had in his slides. Hough gave had some questions. I gave a little bit of a critique of some of the things, and it was pretty good. Then Morgan had reported from where he was in the city, and he was running errands, and he had a little update there. And then I actually presented on something that is sort of personally relevant to our organization, but also more relevant to developing open source projects. And that is the maintenance and evolution of repositories. So I think we mentioned this in the meeting here, our organizational repository was deleted through a malicious attack several weeks ago. And GitHub was able to restore it. And to this day, we don't really know what happened. And but this just underscores the need to have like a really good plan for backing up repositories in their state, in their current state and in past states. And so we talked about how, you can fork things and you can have those forks out there so that work is sort of somewhere else. But still, you have to make sure the forks are updated. A lot of times collaborators will fork things and not synchronize them. So, they're out of sync. Sometimes that's not such a big deal. Sometimes it's bad because, you lose things, you lose commits, all sorts of things. But, also you have this problem of backing up your actual repositories. Now, we kind of tend to think of GitHub as sort of a ground truth, or at least the home repositories being a ground truth. And, that's obviously cannot be true. You can have things that go away, and sometimes you're not aware of when they're going to go away. They just happen to go away. And so this speaks to the need to back things up on a regular basis and have a resilience plan because, we have our resources, and this applies to any kind of set of resources that you have, like drives and emails and things like that, where if something isn't working and you need to access it, how do you access that information? Is there more than one way to do that? So that was something I pointed out. And then I talked about some papers, some articles that I had found on thinking about your repository architecture strategy. So this was a nice blog post on this from Stefan Hiller. And he talks about this difference between a monolithic repository or a monorepo and a multiple repository polyrepo. And so, the decision here is like when you start an organization and you scale up, or sometimes when you start an organization or developing a culture, how do you manage your teams? How do they interact with GitHub and how in version control more generally? Sometimes it's about, creating everything in one repo. Sometimes you use different repos for different specialized tasks. And so if you can do that, then you have a strategy. But the problem is that there are pros and cons to each. And so that's what this article talks about. And so having a consistent strategy is good, but also having a strategy that fits your team is just as good too, and sometimes better. So we talked a little bit about monorepos and polyrepos, and then we talked about the strategies, the advantages and disadvantages across these. So there are advantages to the monorepo strategy, there are disadvantages, and then the polyrepo strategy, there are also advantages and disadvantages. Okay, so that's, and then of course, a lot of this has to do with your institutional culture, how you approach key design decisions and things like that. Okay, and then there was this article on this tool called GitEvolve where they predict the evolution of GitHub repositories. So we just went over the abstract on this, but basically talked about the system that will predict the evolution of GitHub repositories or how they evolve as organizations change and scale up. And so, this is again another thing where if you start a repository, and you start with a certain goal in mind, and then as you work on it, because open source is very collaborative, it can go in different directions. It changes, and sometimes you have to restructure the repo. Sometimes you have to change the name of the organization or the repository. Sometimes you move things into repositories as they become more or less relevant, and so on and so forth. So this is what they were trying to do here: predict the evolution of GitHub repositories. And yeah, I think this is an interesting paper, an interesting approach that they propose, but I think it underscores this challenge of sort of, working through your sort of presence in version control and constantly reevaluating and revising that. So we have an example here where, we used to have our open source sustainability things in a repo called GSOC, and it was just parts of that repo that we had commits to. And we had everything in there. We had a bunch of other things, but that's where open source sustainability lived. And then recently, within the last month and a half, I created an open source sustainability repo that is better organized, better descriptive, and really focused on the things that we're actually actively doing. So that's one example of how you can do that. And it's really just a matter of cloning the old repository, creating a new repository with just the files you want to save, thinking about the structure, and then putting it into practice. And that's pretty much how I approached it. So that's how you do that. So then that was good. Then Jesse had a conversation here, and it was about strategies for kind of thinking about, how you're valued in an organization. And we had this quote from Ethan Mollick, who's a AI person on LinkedIn. And he said, I said it a few months back, and I think it is more important now than ever. If you are considering taking a job offer, you will want to ask what your token budget will be. And that sounds like, that's a pretty practical thing to ask if you're, like, say, getting an AI job. But more generally, it's something that you should ask if you're, what is my role in the organization? Or how am I viewed in the organization? Or am I going to be supported in the organization? And so that's just kind of a, thing. Sometimes a job looks really good, but you don't get support if the culture isn't there or the resources aren't there. So, yeah, and Jesse says, this is a great question because it'll give you some insight into what their AI strategy is. Again, yeah, just how they approach this larger enterprise that you're being hired for and how you fit into that. So that was something that sparked a lot of interest And yeah, and then I'll leave it up Jesse to kind of flesh that out if you'd like.
I really recommend following Ethan Mollick. He's based in the Wharton Business School and he writes well and writes often, and he's sort of like, if you want someone who is very cutting edge and pretty aware and pretty sober about trying to just evaluate what different models and whatnot are doing, I think he's one of the better people to follow at that point of at that vantage point. And he's fairly generous in like, hey, this is a good question to ask in this particular situation or whatever. And in this case of with the conversation that we had, and we don't have to recap it here, the conversation that we had basically about, it was, the question was, hey, ask about tokens or whatnot, but it led into a very nice discussion of how do you get at, as you said, like some of the strategy of understanding what's going on in the organization. It also went into areas about related to conversations that I've had with various interns or just I mean, not just young people, but also people who are just graduating from Ivy League schools, people who are graduating from excellent schools or coming off of different career opportunities, all having the same question about what are we doing with a degree? Like, should I pursue another degree? What are the costs and benefits of that in terms of resources and money and time and like direct benefits, indirect benefits? So it's a very nice. I'm going to go back and try to like clip it out or repurpose it, or even like just say, okay, we had this and let's expand upon it here, because I think it was one of the a very nice collection of what right now contemporarily, in a contemporary sense, what is going on, like what are the questions actually being asked right now, and I think we had a nice range of conversations about perspectives on that conversation. So I can leave it at that for the moment, but I'm happy if anybody here or watched that or has heard it now and has additional questions, please ask them in the chat, or please ask them in Slack, or even some people have specific things they don't, in a DM, or you can also say, hey, Jess or Bradley or Morgan or whoever. It's great that I'll hear, oh, I reached out to a past Google Summer Code mentor. I reached out to someone else in the lab, and I really try to encourage that, because I think that's something, an incredible skill to get used to doing, and the benefits are great. But please, reach out to us in whatever form is best for you. Get used to doing it. Let's see here. I'm going to put these on. Sorry. There we go.
Yeah, thank you, Jesse. Yeah, so why don't you talk a little bit about the Cognition Futures meeting from Wednesday?
All right, great. Can you still hear me?
Yeah.
All right, this should be a little bit better now. Yeah, actually, I'm attempting to edit and do some editing on that right now, and I'm experimenting. It's so interesting right now, as a meta commentary and everything. I think we spoke about this in the context of one of the meetings recently, but just the means by which you're, like the AI handoff component of everything, where you're kind of interacting with these tools, and when it gets interrupted or stopped, it comes back to it. I'm attempting to sort out some of that myself, even in terms of like editing the video, posting the video, or like how are we doing, this different stuff with it. So it was a nice meeting. We basically covered the final beer paper, and I'm remembering what the title of it was. Oh, it was his take on the dynamical cognitive science one. He was basically having a response to, was it Van Gelder? Like this paper from 1991. I'm sure you, uh, I don't have something super easily to show for it, but it was a nice meeting. We explored parts of it. I know Amanda kind of went through it and mentioned sort of five of the 5 points, or the 5 claims, or five aspects of the approach that Beer was getting at. It basically, at its core, was kind of about he was the original paper 30 or so years ago, or through 3 decades of since that it was part of the Beer's paper was part of an article series. I think the Raha paper was part of the same one from last week before. But this article series around 30 years on dynamical cognitive science, or 3 decades of it, and what's kind of happened since then or not. And the paper in the past was Van Gelder kind of, he was like, hey, I'm gonna try to arbitrarily reduce the space that we're talking about somewhat, just so we can have our disagreements and move on. Like, he was making a very particular gesture so that it would lead to further discussion and development. And Beer's paper essentially is a critique of some of that, saying, well, maybe it's more like a language of dynamical systems and a language of computation are 2 languages that you can use to describe what's happening. And he kind of goes into, well, what about like behavior or mechanisms that are producing certain behavior? He offers certain alternatives, but he sort of is critiquing Van Gelder's original approach by saying, well, maybe you're doing too much with this in some form. And it's an interesting thing to both look at the merits of the critique and the whole set of discussions on a personal. This isn't exactly what we talked about, but thinking about it since then, on a personal note about things, there's this element of, I feel like I have even more sympathy for Van Gelder originally, in the sense that I think it's a wonderful and beautiful and awkward lesson in this space where sometimes you have to, at the level of a new bridge or theory taking place, you have to kind of frame something in a way where you're going to very obviously be wrong for a long time, even like there's a use to doing that, and not just, and there's like sort of the Karl Popper, the point of science progresses through like saying the theory doesn't work kind of a thing, like that, like this continually challenging, like, yes, like there's something to that approach, and like a philosophy of history, science, kind of a thing. I think that's Popper, right? But not just that approach. Like, I think in many fields right now, and it's a conversation that I have all the time, and in many, spaces that we're in here and elsewhere, it is, how do you demarcate? Like, I think this is perhaps a stretch to say because I don't quite know, but the history of Van Gelder's assertion for dynamical cognitive science and what he wanted to do there, leading to like 3 decades of pretty well documented critique and discussion. I think people don't realize, like, that's not that's a nice thing to have for a domain space, and that it hasn't always been that way. And certainly there's been many arenas where there's been contentious and rigorous debate on theory and practices, and like that's not an unusual thing. It's just I always have a permanent reference point in my mind, something that I mention for like I'm mentioning when I'm introducing people to a lot of things that are coming on board, is like Margaret Bowden and the 2007 demarcation, and how in like her massive, I think it was like Mind is Machine or something, her large compendium series, she was like saying like that was sort of at that point, like it became somewhat untenable for someone in cognitive science to know all the diversity of branches and thoughts that were happening. And I think it's an interesting reference point because that was both before, before deep learning, before LLMs, and before all this other stuff. So to put a bow on my part of this, and I'm happy to hear from Bradley or Morgan or anybody else. We had a nice discussion about the paper, and I forgot what we decided we were going to do next time. I think, oh yes, I remember now. We're going to go to one of the other papers in the World Models Special Issue, Royal Society A, that we were also published in. The Avery and Amanda kind of found one they wanted to do there. So we're going to go back to that space and look at, I think it was like topological implications of some things there. The topological paper, I think with Levin as one of the senior or later authors on that. That should be good, and kind of just, more at large, that we're kind of just getting the band back together about some things. So it's good to see Amanda kind of doing Amanda's stuff and Amanda takes, and Avery. Oh, I should also mention Avery presented a little bit on allostatic kinds, which is sort of their long-standing project and ideas that they've, made and then presented a little bit, developed, put on the shelf, come back now with some new things and new takes on it. And their allostatic kinds is sort of an approach to regulatory weights and imbalances or biases or preferences that individual agents have, and how that might it is also commentary on the agent in an environment as well. It's not quite vertical horizontal causality, if you will, in the Fuchs sense, but there's some interesting overlaps between that they're fleshing out, doing some archetypes around those kind of processes and informations. Men seems somewhat interested in that as well. So we'll probably hear from those updates ahead too. Finally, the last thing I'll say about this, it did not come up in the meeting. I mentioned this in chat though, or in Slack. I would like to find the old papers on, it was like developmental freedom and developmental capacity. I don't know, probably 3 or 4 years ago now. Because one of the things that JoPro is doing and sort of incorporating, this is my own personal, I should say, I'm doing this, and JoPro is supporting me in looking at this. It's not necessarily a JoPro sanctioned or orthogonal lab sanctioned project yet, but I have a vision of somewhat in line with the 1943 papers and Levin's sort of repeated attempts at trying to better categorize both agents, or artificial and biological agents, a more unified principles that would cut across both substrates or embodiment types of agents, if you will, diverse intelligences, a la diverse intelligences. I have a project that I'm working on that would look at things like developmental freedom, maybe a little bit of metabrains, some of the mental health work, Cognition Futures stuff in general, world models, something that's a bit synthetic and perhaps ambitious, perhaps aspirational. But I'm trying to not quite assemble the infinity stones. I think it's more like some loosely polished pebbles that I'm trying to assemble maybe into a kind of, a rudimentary, a crude mosaic-like thing. That's where I'm going with that. But if you ask me what's happening in Cognition Futures besides we're reading some papers. Amanda's kind of maybe continuing from some of her old Cognition Futures stuff, embodied neural phenomenology. Avery's got Avery's sort of allostatic kinds and taxonomy of affordances work going on. Maybe Bradley and Orthogonal Lab and the spirit of the cybernetics reading group, which I'm open. I would like to kind of find maybe a synthetic name or something. I'm just calling it the Cognition Futures reading group because that was like my most original association. We can change it. So we have these sort of nice themes of world models, allostatic kinds, Amanda's philosophical cognitive inquiries into what is. Let's look at we have important things to look at in human cognition that isn't all about AI. Like I really like that perspective is centered as we're not gonna have someone who's just gonna willingly let's go and talking about AI stuff all the time too. I actually really like that. And then me with whatever. I'm not even gonna try to categorize myself more than I already have right now. Up my meeting and then broader Cognition Futures space update. And I'm happy to have Bradley say more or anyone else.
Yeah, great overview and talking about a lot of the salient issues that are bubbling up from that meeting series. I do have some more information about developmental freedom. I've been kind of using Gemini and Notebook LM to summarize some of that from the papers and slideshows, and I'm kind of working through kind of what it's kind of generating a kind of a synthetic description of what that is. So like, going across the different papers, I think we've talked about developmental freedom in slightly different ways, and I just wanted to get a handle on what that is, like from the different descriptions.
Yeah.
You'll find this a lot of times if people write a series of papers on something. The description changes because you're always thinking about it in a new light, so you want to bring everything back together.
I super clearly, in my mind, there's like, I don't know the exact words, obviously. In my mind, there's like one or two paragraphs within one of the papers, and it might have been just a preprint. I don't know if this one was ever like submitted to a conference or not. But there's like one or two paragraphs that I really want to find where one, the concepts was defined, but then also like it was a particular snapshot of how we were thinking about it at the time. And it's like, oh, I gotta find that is. So I find which one it is. So I don't know if you're gonna make one of those synthesis videos, or there's like a rummage around through some of our past papers, and I don't know, maybe it was on the organization. I don't know what repeat page or the organization macro repo. There was stuff there to look through too. So I'm gonna try to rummage around to that. But anything you find, I'm happy to look at.
Yeah, I think that's something that we can revisit. And yeah, I might do a video actually.
Yeah,
it'd be nice to have that as a reference. I don't know if it would be, but maybe it's better as a video or like some sort of hybrid where I make slides or something.
Yeah, even like a very simple, even something maybe like a small, it could be a very small video, like just sort of here's paper 1, paper 2, paper 3, and maybe like here's how we talk about it in paper 1, like a sub slide, main slide, sub slide, like that kind of that would be great. I mean, I don't know how much work that would be, but like I'm gonna have to do something like that myself, probably in some form. So
yeah, that's good. If we have any other comments or questions on that.
I have a few other updates that aren't related to this, like data interaction update this week. Diginess, we met last night briefly. But for Cognition Futures, that's set, and absolutely interested in developmental freedom as you assemble anything about
Do you want to do the updates now for data and direction?
Yeah, they won't be long.
Okay.
If anyone from that, I invited them. I loosely, I think if people come, it'll be more likely in the next week or two than this week. To our Saturday meeting. The first meeting was great. The first cohort meeting. Basically, what we're trying to do that we actually can do this time. There's a space on Wednesdays where pretty much everybody in the cohort can meet, which is kind of amazing. We have currently, and I'm working to both. It's a dilemma because it's kind of like Google Summer of Code. Like I only have finite time, and I'm the main person for the. If I had certain other people or could combine some projects more easily, it might be a little bit easier to do more. But currently, there's 4 undergraduate students and one solid graduate student and 1 to 2 that maybe will be part of it indirectly, and they all were able to meet Wednesday on somewhat short notice at kind of as sort of our week 0 preliminary meeting where we're just getting used to stuff. And then what we're doing and ultimately is I'm having just one-on-ones to get to know people and sort out their projects for the term. It's basically a center bridged Google Summer of Code setup. It will basically be, I don't know, roughly 10 weeks or so of working on things in the summer. Some folks want to do something that's a bit more technical. Some folks are interested in one individual who recently graduated from a very good program I said to them during the interviews, like, hey, you may be like slightly overqualified for some of what we're going to be doing here, but I'd love to do this at a certain approach for you at a certain angle. And what I'm realizing is one, they were like, oh, I do want to do some project stuff, but I also want to talk about strategy and professional development and developing my arguments and sort of this more applied, how do I communicate and get to know this space? And I actually had someone else, not at all in the program, find some of what I posted on the internet, on the new website and other things, and basically reach out and be like, hey, I want to both understand this and do some more of the contextualizing work and get used to like being in interdisciplinary spaces as well. That's maybe less of a data injection, more of a Jerko thing at large. But point being, I'm more than I've realized. Well, I've said this recently, but just yes, a lot of fantastic candidates and very lucky for that. But also just there is a real need that I'm trying to address. Am I getting it perfectly and what I'm trying to offer at people as they're coming to try to understand more about data and direction or understand more about operating in a space that's like responsible ethics or responsible AI, data ethics, human flourishing, whatnot, like building the sort of on-ramps and pipelines so they can go do cool stuff in that space is a work in progress for me and for like every other, it's a challenging space to be in, but people are aware of that and willing to work with that overall. And so the cohort that we have, like, it's just starting out, but everybody in it, I look forward to talking to them, just talking to them over the summer, no less really cool projects. I won't get into what they are, but some of them we haven't had the discussion yet. But 1 or 2 folks are finding some very specific things they want to do, and one of them is a very interesting take on multi-agent or more so multi-instant systems and, let's say, unconventional ways that might steer or guide certain behaviors or ways of interacting. We had a discussion last night in Dizziness about the the foundational instructions to give an LLM, right? Like here's your main things, and how do you deviate from that? We've talked a lot about drift, persona drift in that sense from assistant, archetypes or personalities or whatever. But looking at these different ways where there's multiple points of interaction in a community or an environment or an enterprise situation, with the sort of one to many, but that one is also several instances of the same agent or LLM, and like how does that environment or set of interactions what are some interesting regulatory things in that space? I'll leave it at that about that project. But it's been cool to see people that people are very interested in the spaces, and people are like, okay, we want to go in here, learn stuff, and try to make some things or figure some things out. And it's going quite well. I'm very pleased with that, and have a little bit of the here's my perfect vision for what I want to see here, and here's a perfect presentation that I want to make. And it's like, sometimes you just have to go with it and make it as best you can, even though you have all this preparation. When it hits, like, oh, you're in it, so now it's just things are rolling, and it's exciting. And I'm very, very happy that everyone's I really appreciate everyone in the program so far. And then very quickly on DigiNest, we had a discussion about it was a reply kind of, there was the 3 decades later from the Van Gelder and the Beer paper. This was more like 5 years later, after the stochastic parrots paper, which is sort of this landmark, is an interesting critique paper from Timothy Brew, Margaret Schmitchell out of Google AI Ethics, and others in the Google Ethics team at the time, which became both this iconic reference point for AI criticism and a huge moment in time for people realizing, oh, Google just like destroyed their AI ethics board, and this big kerfluffle, this big controversial stuff, and Google's motto used to be do no evil, kind of stuff. And so I was looking at that 5 years down the road, and the paper was essentially critiquing how it was a preprint paper that was offering a critique of people who are concerned with AI ethics shouldn't just say, like, you basically challenging them to do more by saying, don't just write off AI hype as, oh, you're just talking like it's a stochastic parrot, but do more than that in terms of look at the existing impacts right now about things like how it's affecting different labor markets, how it's affecting comprehension. They made a comparison to past revolutions, the typesetters and cultural moments of change and all. We had a very nice discussion. Avery co-hosted the meeting. We had a new person join as well as kind of a audience member, if you will. And it was a good and fruitful. It was a good discussion around, that trajectory of things. Avery never. Avery wanted to. Previous week we looked at the actual original stochastic parrots paper, and kind of Avery wanted to kind of do a deeper dive on that. So we're kind of on a little bit of arc of that as we return into some other things. But that's what that meeting was about. It was a nice meeting. I'll post something about that soon. But that's it. Summertime is like, okay, there's like a full load of Monday, Wednesday, Friday, Saturday. Like, that's like 5 things in the Joe Pro community. That's I made, like, hosted in DevoWorm, hosted in an orthogonal lab, some of like these things. So it's just like, even bringing people into the new system, it's like, hey, here's like this current roster of meetings. There's a lot going on, so it's a fun time.
Yeah, thank you. Yeah, it's
Sorry, my audio just cut out.
oh yeah, thank you. Yeah, it was great. So yeah, revisiting the stochastic parrots paper, I think it's useful. I know they do the that group does a Twitch stream.
Dare.
Yeah, Dare.
Yeah, it's for those who are new. Tim and Brew basically left Google AI and made Dare, the Distributed AI Research Institute, and they have a very, you know, their approach to things is interesting and quite different. And there's different elements of controversy in how they approach certain things, and different members talk about stuff. I'm not fully endorsing anything, but I do think one of the things that came up in the paper and in the discussion was also how it is valuable or interesting to get the perspective of like the data, like the underserved, if you will, data workers, the people on who are kind of like, looking at the stuff, the unseen human impact of big AI and model training and both that sort of thing. Yeah. So you were saying, sorry.
Oh no, I was just reminding us of the Dare live stream. I don't know if you've like caught up with sort of their current thinking on it. I mean, that's usually kind of, you write a paper and then you kind of reflect on it over time, and then other people reflect on it too because it means something to them, often something different than it means to the authors. So.
I think for those in our deep orthogonal lab lore community, there's a little bit of a semblance. We just for some fun big intuition parallels. It's not quite 3 decades later, Van Gelder and Beer. It's maybe a little bit closer to the spirit of, if not the time, the spirit of this. The paper we read was based more than the spirit of the Martini critique of embodied cognition, which is very deep cognition. It was like one of the first things in the Cognition Futures review we looked at. Martini was critiquing, did Cognition Futures kind of the same as what happened to cognitive science from Nunez? But Martini was saying, hey, like, did we really get embodiment right? Like, are we using things like, I wonder what Martini now would say about Jan LeCun's effort to get all of this first person video and all the direct stuff, because that was kind of his critique was like, do we actually like, did we really center embodiment enough? And are we not using video as a means to deal with that kind of stuff? So I think this paper that we just read in Diginest was a bit more, not quite, definitely not isometric or isomorphic, one-to-one comparisons, but kind of more in that spirit of, hey, like, don't get caught up by the hype around using. Don't use the phrase stochastic parrots to just like, oh yeah, big AI, ooh, like it was kind of, it was challenging the community to be a bit more like, okay, like let's look at the real things that are happening right now, and not just sort of like losing sight of that and worrying about like some broader implications of AI. It didn't say like, I don't want to say like AI consciousness stuff specifically, but just what's happening right now. So yes, we can move on. Yeah.
Right. Yeah. Well, that's great. Yeah, we should continue to think about that. I guess more in that vein of revisiting society, ethics, tech, and kind of the current state of what's going on there. Yeah, I mean, because there's a lot of stuff going on where you could just grab something and say, "This is a concern," or in light of, if we go back to stochastic parrots, this is a concern that they were addressing 5 years ago, things like that.
And that's one of the analogies that's coming up a lot is like I'm referencing sort of the FDA timeline a lot, and when I'm introducing people to data and direction folks, like I think it's important for people to understand, one, that everything's moving so fast, and two, a lot of our structural ways of dealing with technological change or implementation at certain levels is just designed for a very different sequence of events than what's happening right now. Like, though I reference all the time to the Sam Altman being like, yeah, people are just going to get used to there being a lot of videos that are fake and videos about themselves that are fake, and it's just like these, like, this is not the same as FDA clinical trials for a medical device, and that's okay. But like, we're in a world where that's so even in the context of Stochastic Ferret's paper, like, what was sort of an insight, like, even that paper starts by saying in the last 3 years, which was at the time like 2018, 2019, 2020, and like a 3-year sentiment, a 3-year like aggregate sentiment on the direction of like language processing and language models and how AI is interacting with these things versus the last 3 years. Like, those are very different 3-year segments in terms of how much some things are in the face of people even. So anyway, I feel like I keep getting sucked in the whirlpool of that. So we'll probably move on and talk about other things.
All right. Thank you, Jesse. Yeah. Oh.
I was trying to see. I was seeing if Avery and some others might have joined, but I don't think they can right now. So
yeah. Okay. Looks like Morgan is maybe wanting to give an update.
No, I was just trying to figure out my camera.
All right.
I mean, yeah. Give me a second, because I'm just it is nice. I mean, I got to say that I've never used OpenAI, but the cloud remote control is the way you can you never have to stop working.
Right.
except when your remote control systems need sudo access, or like, they need you to run certain operations.
Yeah.
But yeah, I got something cool in terms of looking at again, just thinking a lot about benchmarks of foundation models. So talk about this in a paper from UCSD on FM scope is the name of the paper. I'll just drop it in the chat.
Is this foundation model scope?
Yeah. So here, I'll drop the paper in the chat. One sec.
Okay, yeah, this is the identity trap and EEG foundation models.
Yeah, yeah. It is so. Ziping Zheng is the co-director of the Schwartz Center for Computational. Is it computational neuroscience? I think. But he does like the center focuses on EEG, or this is Scott McCaig is the other co-director, and sorry, I don't know if you can hear that siren. This is the lab that develops EEG Lab, which is, it's probably still one of the most widely used EEG processing packages. But I do think that this is something that is relevant for other modalities, right? And what yeah, so just thinking a lot about how to do, like at least at this point, this is more of like a BCI, right?
Right.
But you can do that, like with the Sophant group. The MedArc is the open science group.
Right.
They are doing that with fMRI as well, you know. So it's an interesting it's an interesting some interesting issues that they bring up, especially about these kind of small data sets. And I thought this was particularly relevant because we've got this package is the, you know, I still, this is probably Neurotech X's most it's not our most starred project, but I would say that it's definitely the most it's the most active starred project. And it's filled with data sets that are probably, you know, relevant to this FM scope like analysis of how much are you kind of memorizing subjects and versus finding the underlying representations. And the yeah and this is also super relevant because you know, talking about how we're in a different age. Yeah, Moab reminds me of a project from the kind of pre deep learning age. It's definitely a pre scaling age, right? Where, you know, again, this is where you could, you know, write a master's thesis or potentially even a PhD with, you know, a data set with like under 100 subjects, you know, and be and like, and that would be a lot of work. Right? It's like like this is not to minimize in any way, shape, or form like how what a monumental effort that would be. But you would, you know, I mean, I know this because I've like had grad students come to me to talk about this project and say, you know, I can't believe, I wish I'd known about this project before I'd gotten started, because yeah, they were either the person collecting the data, and again, you know, if you're one person collecting data, like if you're going to get 50 subjects, you know, like that's a huge amount of work, right? As well as like someone who's potentially writing the analysis classification pipeline, right? So, you know, you're developing some novel classification pipeline. You would have to be the person to write the new one and write the ones to compare it to show that it's better than these things, right? And you know, it's nice to think that everything is available as open source, but you know, again, this was not the case. And you know, this was one of the nice things about Moab, right? Was that like it was a set of data sets, and it was a set of, we're gonna to use the current lingo, we'll just talk about state of the art algorithms. But it was basically classical ML pipelines with a cool particular French twist with this Riemannian geometries for classification, which is cool stuff. I mean, you know, it's nice stuff, and but it's certainly a big part of a lot of deep learning methods now, especially if they're coming from the kind of like PyTorch geometry world, where they're considering manifolds and things like that. So but yeah, so grad students become saying, this project could have completely changed how they did their work if they'd known about it in advance. That said, this is even when you combine all these data sets together, it is still it's a great effort, but it's not what we would call like a scaled effort. Not certainly not in the tech sense, and not even in the medical imaging sense. Right. So the current FOMO 26 challenge that we're doing with MedArc is doing for MICI, is using a data set of 300,000 MRI scans. Right. So this has got a much smaller number of some of the data sets that are in here are very small, and so it's saying now 3,500 subjects, and so I'm curious what that's going to include. One of those, I assume, is a new data set that they've added that has like 1,000 plus. Somehow this has been bumped up with like one particular edition. But yeah, this is it's an important consideration that I think we can actually bring to other like topics of medical imaging. And so it's like I've already taken this FM scope analysis and I applied it to a large data set of MRI scans, where we're not looking for subject, but it's the Child Mind Institute Healthy Network data set, which is actually collected across 4 different locations. So that's another thing that you can use this to actually see, again, kind of like how much is it's kind of breaking apart what's trying to do a kind of interpretable AI approach that also kind of reminds me about like doing diagnostics and other techniques in statistics. Like when you're looking at a general linear model and you're trying to tease apart like the interactions you have, what happens when you control for this, what happens when you control for that, and trying to bring that to the foundation model results that you get. So I think it's more general than just EEG.
Yeah. So yeah, let's see what these papers look like. So this is the identity trap and EEG foundation models. So basically, they talk about these FMs or foundation models for EEG. They report strong accuracy on clinical resting state EEG, but high accuracy under subject disjoint cross-validation remains ambiguous. It can reflect a genuine clinical marker or subject identity features that correlate with the label. That's what you're talking about with respect to like individual variation and versus like an actual effect. We name this the identity trap and ask whether it can be diagnosed at the representation level before fine-tuning. So this is where you're trying to remove basically artifacts of individual subjects. And so that's what they're doing. So they propose FM scope, which is a frozen representation protocol packaging 5 diagnostics. We applied to 3 pre-trained foundation models across 4 data sets. And then they find that the identity trap is universal. The dominance is this dominance is a removable linear axis. Erasing it improves label decoding where the label varies within subject. And then aperiodic 1 over F noise is 1 subject carrier. Removing it drops the subject probe. And then fine-tuning amplifies label variance only in cells of the literature established cross-subject marker. And so then the identity trap is a physically grounded instance of shortcut learning. The preferred cue is a measurable physiological component, and subject disjoint splitting alone cannot rule it out. FM scope separates gains reflecting a biological marker from those reflecting subject identity. So that's very good. Yeah, I mean, I'm glad that they kind of dug into what a foundation model is, and maybe some of the caveats of combining a lot of data and then thinking about things beyond mere correlation and kind of getting at some of these things. Getting at maybe some of the things that can make a foundation model not so predictive. Go ahead.
Yeah, I was just gonna say, like, this is interesting to just to give you, something EEG that we are going to be doing, which is this this company that is doing, showing pictures to people and then trying to predict what picture they're seeing from just their EEG trace, right? Is doing this kind of like, we've trained on this data set, we've got this data set of say 10 or 20 subjects we've trained. Now we're going to fine tune it to the person that's now sitting in this chair.
Yeah.
I lost picture. Sorry. That's what this is going to be perfect for that, or like be, the what we hopefully have is we do have a demonstration example where it's like we should be able to fine tune better and more accurately, faster and more accurately, if we can remove this confound, and I guess what you'd call, it's not pre-training,
Right.
but before fine tuning.
Yeah.
Right.
Pre-confound removal or something like that.
Yeah. I'm still learning my terminology. Anyway,
Yeah.
but I'll drop a link to this because I like this particular company in terms of what they are trying to do.
So if we go back to the GitHub repo, so this is the GitHub repo. We basically have an initial public release, and so it's a diagnostic toolkit for auditing EEG foundation models. And then they have 5 diagnostics. They have a variance decomposition, subject access erasure, aperiodic or Hough ablation, and then layer-wise probe, and then direction consistency. So these are, the first one is the subject identity dominate the representation. The second is that dominance confined to a linearly removable axis, and does it help to remove it? Then the aperiodic ablation, which is is the 1/f spectral component of the carrier of identity. So there's always this 1/f spectral component you can remove or not remove. 4 is at what depth does the label become linearly separable? And then 5 is, do subjects encode the task contrast along with a shared direction? So these are all, quite relevant to data analysis. Yeah, and then I guess you could audit your own data with this code. You can reproduce the paper that we just saw, and then you can bring your own data set or use some of their data sets here. All right. Very good. So yeah, thank you, Morgan. And that's hugging. Oh, the hugging face.
Well,
So
I'm just sharing the all joined. So all joined is this this company that's trying to do, kind of like the EEG version of MedArc, or the Mind Eye project.
Yeah.
So it's like if you go hit the alljoined.com, just because it's got a nice yeah, you can see their headsets in action.
Yeah. So this is Enigma.
Well, yeah, it's a different Enigma. It's funny. Okay, yeah. So that's the CEO and actually one of the engineers. But I think Enigma is what they're calling their foundation model. I forget. There's too many Enigmas. There's like the Enigma that's working on like neural representations. There's the yeah. Anyway, I'll let you get to let's get to more presentations. But I do want to see what you can get from this in terms of improving the kind, this particular kind of use case of foundation models, and if it can be a practical, this is obviously super relevant for NeuroTechX, and some things that I'm trying to get started with student projects. But
well, that's great.
Yeah.
So thank you. That was good. Good to kind of visit that world and see the state of the art there. So it looks like Kavya would like to present. Jess has been setting this up.
Yeah, so actually, we were just discussing whether I can present the doc which I had sent to both of you. The idea list. Okay. So can I start?
Yes, go ahead.
Yeah, so I had actually listed down 2 to 3 ideas based on some papers that I went through. So first idea was to add stage development to active inference agents. Like I could not find a prior work where they have used active inference and stage development, like moving from juvenile to adults. And I did found structural learning papers, but not this type of papers. Also, this was just an enhance, like we can add endogenous transitions rather than moving development through fixed time clocks. And it seems to answer these 2 questions. The first idea, whether does a phase structured prior schedule produce better generalization than a uniform prior schedule? And does the agent that decides its own transition timing outperform the one on a fixed clock? So these were some of the papers that I went through. Like first one was the foundation paper of active inference. So it talks about uniform updates, but there are no developmental stages within it. Second was beyond the adult mind paper. It's mostly a theoretical paper where they have discussed that predictive processing is a little bit inefficient to account for cognitive development in infants. Like, just to explain, they have not told that it's not correct, but in order to explain, we need a complete theory of cognition. Like we need an agent that starts from nothing to a fully developed model, like how a newborn who starts with no model builds up sophisticated models. The challenge PP mostly describes incremental updating of an existing model, but babies need something far more radical. They need to construct entirely new structures from scratch. So this was the challenge that this paper discusses. The gap was to introduce a flexible starting point and a structured learning toolkit that this paper addresses. Active inference for learning and development in embodied neuromorphic agents. So it's a paper that discusses that in order to show a true intelligence, we need three things: a body, learning through physical interaction with the environment, neuromorphic hardware, brain inspired computing that process information the way neurons do, and a developmental approach like learning that progresses from simple to complex. The fourth paper was emergence of goal-directed behaviors or active inference with self-prior. So this paper proposes how goal-directed behavior emerges in early developmental stages. Like they modeled a child with a sticker on one hand, another. So without any rewards, the child removed the sticker due to mismatch between the internal environment and the external. So the experiment also proved that infants aren't stubbornly fixed forever. If a change persists long enough, the infant's brain will eventually update its baseline. So another addition to the first idea would be to add heterochrony, like to extend and see how different developmental windows affect, like in uh, different stages of life. What if one stage of life is given more amount of time than the other, like something that happens in C. elegans as well, I think. Like in larval stages, if one window is much more open, it mutates. So again, I could find some papers on critical periods, but mostly on neural network and not on active inference part. So that gap still remains open. And the third idea would be to extend this paper of goal-based NCA. They have shown that the neural cellular automata is somewhat robust to loss of data. Like if there is a 40% loss of data, it can still uh, somewhat get to the end goal, but there's a gap that what if the data is damaged? Like, can the NCA recover from partial information rather than loss of data? What if the data is damaged? Yeah, so these were the three ideas that I just shortlisted down. I just wanted to know whether which idea should I go forward with, or are there anything that you suggest?
Hmm. Yeah, this looks pretty interesting. Could you scroll up again?
Yes.
So yeah, I mean, definitely, um, thinking about all these different mechanisms that you could sort of incorporate into the work. So you have, of course, the reason why we want to pursue development. Well, there are actually two main reasons. One is that it's not like adulthood. So you usually have like the origins of an adult network or an adult model or something like that. So, like you say, at a development phase like juvenile, brain is more plastic, and we assume that the developmental stage is weak priors versus adults who have strong priors. And then we could add in something like a phase transition or some sort of clock mechanism that would like kind of time out that transition from development to adulthood. So I mean that's kind of one reason we do it. Another reason, of course, we do development is because we're interested in this nature versus nurture question, which is that if we have sort of nothing as the origin of your prior, how do you gain a prior or a strong prior? And the answer to that, of course, is you collect data or you acquire information from the environment. But then there's that process of development. So that's kind of what's interesting there. And then you can, of course, add innate features, which are things that are sort of hard-coded, but they're not deterministic long-term. Like, they're there to give the sort of maybe the set of priors that's, just something is like almost like a set of training wheels, where you have things that you inherit, that you start with, the tendencies that you move towards, and then plasticity might move you away from them as you learn, that sort of thing. So that's all kind of why we do development. So I think some of these approaches, like you're kind of going into the active inference direction, which is where they're interested in kind of this sort of gradual improvement using Bayesian methods like priors. They're interested in epistemic aspects of that model, where it's like, what does the knowledge look like? And then, of course, you have predictive processing, which is kind of part of active inference, where you have some sort of neural model that can do prediction of things. And processing is a predictive act. So neural processing is about predicting things in the environment. If you encounter things, if you get information from the environment and you acquire it, then, if you see something that you've seen before, then you use that to predict maybe the source of food or maybe some other connection that you can exploit. So that's predictive processing. And then, this is something that, of course, we can't necessarily use in development because it's inadequately defined as the theory is defined today. I mean, like this area, like of predictive processing, is like hotly debated in the cognitive science literature. So, like, if you were to go in that direction, you'd have to engage with those critiques and especially in terms of development. Like, you have to really kind of dig into the literature a bit for that, to make sure that we're answering a question that people care about. But this, I think, is a nice question, though, that you have these things in development, or you don't have these things in development that you acquire through development. So, like predictive processing, you don't necessarily see it maybe in early development because you don't have any priors or you have very weak priors. But as you move along, as you gain experience, then you gain the ability to do predictive processing, basically. So, I mean, this is, and I have to say, though, a lot of times people talk about babies and newborns, and it's like, this is very human-centric. So there are a lot of other types of developmental systems where, we could draw from as a biologically inspired model to kind of bolster the arguments or gain inspiration for different approaches to this problem. Like, for example, there are a lot of organisms that have a lot of priors that they come with, or I'm sorry, a lot of innates that they come with. And it's a matter of going from sort of innateness to, plasticity coming online. And so that's kind of maybe another way to do this as well. Move down a little bit in the document. So, yeah, we have embodiment, of course. We have neuromorphic hardware. Neuromorphic hardware, that's something that is, we can also look at like spiking neural networks and things like that as the software equivalent of that, where you basically are drawing from sort of the hardware of the brain, as it were. I don't like to say it like that, but like it does draw more from this. It has this inspiration of implementing something in hardware rather than just simulating like behavior or simulating a very broad representation of what's going on in the brain. Yeah, I think maybe that's maybe not as sort of central to what we're doing here, or it would be a little bit harder to implement that. Embodiment is a very important part of development, of course, we have, of course, we would like to evolve our agent's phenotype along with the behavior. So if we're talking about acquiring priors in development, you're acquiring priors from the environment, but you're also acquiring it from the phenotype as it's shaping. So as you gain length in your arms, or you gain, the ability to coordinate your arms, or you gain the ability to coordinate your legs, you can start to walk, basically. So, if babies learn how to walk, it's because they have this prior motor circuit that allows them to walk, but they have to coordinate it through learning and plasticity, and so that's what they do. And so that's, the whole process of learning. You learn that prior through some innates and some experience with the body as well as with the environment. So that's kind of how embodiment fits into that. Then you have goal-directed behaviors and active inference. So again, goal-directed behaviors are, I guess you have to sort of start from a non-goal-directed state in your infancy, and then you move towards goal-directed states because you learn what those goals are, or you learn kind of how events kind of move towards an end, at least in cognition. And so that's kind of what this is. I think, negative feedback. And so Jesse's interested in this area. I mean, he's written some blog posts on that. We've talked about this cybernetics paper where they lay out this taxonomy of different behaviors, which we can talk about. But I think, I think one of the key things here is just kind of saying, what is development? What does it mean to develop versus be an adult? What does it mean to have a body or to kind of grow into an embodiment, or to grow an embodiment from basically nothing, and that sort of thing. So those are all important things. Can you move down a little bit? Yeah, and then so of course, we want to implement this in some agent. We have, we've worked a lot with Brainberg vehicles. We can embody it in a generic agent. I mean, we don't have to embody it in any specific agent. And then there's the NCA, which is the neurocellular automata. I think that's neurocellular automata are interesting, but it's kind of something that is, I don't know how well integrated it is with some of the other questions. I know that they have sensory motor Lenia, which is a software package. Lenia is an approach that was developed by Bert Chan, I believe, at Google. And it was a set of approaches where they have these continuous cellular automata. And I think NCA is actually kind of part of that whole area of inquiry where they're developing cellular automata that kind of fit in with embodied models. There have been some attempts to model development with NCAs, but it's largely kind of seeing if you can match a template. And so I don't know if there's if you can do really effective developmental modeling of agent behaviors using NCAs or a sensory motor Lenia. Well, I know the sensory motor Lenia, they've tried to do development. That was actually the Pierre Audier and his group in Paris. But that's something that maybe we try a more conventional model first. But I think maybe focusing on the active inference components would be good. And then thinking about the difference between development and adulthood, and then getting into some of these other questions. I see you have heterochronia on the list, which is of course the timing of development, and that's of course important for how things are acquired and how long you're exposed to them and how long the embodiment grows, as opposed to, in direct correlation with the exposure of something. yeah, we've talked about critical periods as well. But the first thing I would do here is to get down this distinction between development and adulthood, and then think about, like, what is it that we're interested in looking at? Are we interested in looking at how maybe some task is acquired? And this is like in how they've used development in AI. I think in the past has largely been as a mechanism for improving training of models. So you're training models by having them acquire data, and then you want them to generalize. You want them to learn associations. You want them to do all these things. But a lot of times acquiring data is a hard task for a lot of agents or for a lot of algorithms or models. And so it's very hard to train something and get it to work, and have this world model sort of there available to it. So the developmental schemes have all been kind of, how do we do this more efficiently? But in like computational agents, then we have this additional layer of, like, if you were using a robot, how do you get the robot to learn tasks like sensory motor coordination? Because it's not just as easy as giving it instructions, because it has to work within an embodiment and coordinate everything. And giving instructions is very hard. It has to be able to explore different options and then implement a solution. So I think that's, I think I would start with that distinction between development and adulthood, and then move into some of these other mechanisms, maybe like critical periods and heterochrony. We might also talk about like priors as a general principle for, how we make, how an agent will sort of formulate a way of doing things. So, if you don't have experience with anything, you can't really have strong priors. But once you get experience with things, then you can have strong priors, and it allows you to be more predictive. So those things, I think, all fit together in a very interesting way. I know that, like, in terms of finding something novel to do, that active inference space, I think, is quite fruitful, because I don't think anyone's really kind of gotten into thinking about active inference and development and what that means for sort of acquiring knowledge or acquiring priors and really working that out. So I think that's actually a very good place to focus on. And, active inference is a really hot field, I guess, or has a real strong interest by a lot of people. So, yeah, I think that's a good way to go. Right, Jess, you want to say something?
Oh. No, Kavya, you can go first.
Yeah, no, I was just saying that I also found some recent work where people were combining active inference with LLMs and trying out different things.
Yeah, there's a lot of combination of things. Like, people are, active inference is kind of a framework for understanding. So it's like a theory, but it's not really a theory. There's this whole debate of what a theory is, but so it's a framework, I guess, that's predictive. And people will use this in different settings. So if you go to the Active Inference Institute Symposium, you have people applying it to all different areas, like large language models, biology, medicine, all sorts of things. And so it's just a matter of figuring out how that fits into what you're interested in. Yeah.
Yeah. To that end, I would say, I guess it's the free energy principle, but sort of the principle versus theory stuff, and the principle as like principles not being able to be disproven, but does it fit the principle or not, kind of a thing like that. That was maybe a useful way to think about some of it, but more so, I wanted to jump in and say what have deep, long-standing and whatnot interest in related to what Kavya's been discussing is anything that kind of lends to highlighting, because what, basically doubling down a bit on what Bradley said about the difference between development and adulthood, or how I think one of the most, especially in a human sense, and this is part of mental health paradigms perspective that Joe Pro is part of. It's an inherent part of Cognition Futures, but not necessarily. Not Cognition Futures is a bit more broad than like specific applications of, like, we're not talking about the DSM there very much, which is like the manual for mental health evaluations and whatnot. But where I'm going with this is, like, I am very interested in things that try to look at and demarcate well the ways that different stages of development are, let's say, non-uniform in their capacities. And like we kept talking about, I asked Bradley, what about developmental freedom? It's sort of this concept we developed that addresses some of this, or at least tries to offer a lens of the trade-offs between where the progression in someone's developmental process, and certain things are more flexible, certain things are less flexible, and kind of like the idea of when a small animal or a mouse, is one of the things I did in an old neuroscience lab a long time ago. When the reason that a baby mouse, or for example, cannot entrain itself and develop a circadian rhythm in the way that an adult mouse can, is because the little of the hardware isn't there yet. Like, the hardware has to mature over a couple days so that there can be something that seems like a broader circadian rhythm taking hold in the whole body, right? So it's like there's these different components of when things come online and what kind of regulatory systems actually begin operating at what level, and so on and so forth, and what's before, after those states, right? What's sort of the sunsetting of those states, right? And I guess, like, I'm very interested in things that help to demarcate what those states, or, if Avery was here, macro, not just allostatic kinds, but the allostatic points of these systems as the different regulatory components come in and out of operation across developmental periods. And then, yes, in the Bradley sense of the difference between maturation and development and adulthood, as a particular, like, a lot of the things that we talk about all the time, we use language of, in precise biological language, like, in the adult human being, or in the adult field mice, or in the adult, insert organism. But in many spaces, and in a lot of common, especially human side of things, we don't always have much. A lot of our models and perspectives are quite shorthanded to very long-standing issues that all people and brain, everything is referred to a very particular model of what a person's experience is. So things that bring nuance to what that is, and yes, I'll go. I don't like going here in a critical theory or ethics component, but yes, the many models are basically built off of the middle-aged white man as the point of reference for many models, or health, or normativity, or standards. So that's like one branch of it. But even beyond that, like, sociological component, just bringing the nuance into the developmental states, I think, is something that I'm very interested in at large. So I'm glad that you were putting this together. Like, I don't know what next steps you have in mind, Kavya. Bradley's pointed out some things. There's a fairly rich history in the lab of stuff that you can point out, or that we can point to. And I'm definitely excited to see where you go with this. I think I kind of wish Ashley was here because I know Ashley was talking about this, and I don't think she was at the last meeting either. So I wonder if she will be interested in that as well. And they might have some other folks from across the lab or in JoPro that are. There may be more interest here than it seems because you're the only person bringing it up in the meeting right now. But I would say like you could find you could find some folks that are interested in this if you want to continue to develop it out. And not saying they all have to work with you or be teammates or whatever, but people who are willing to talk to you about this, they are here even if they're not in this meeting right now. So that's my 2 cents.
Yeah, thank you, Kavya. It was very good. We'll keep working on this and working through it. Let me know like what your thoughts are, like offline about this. Yeah, I think it's definitely like there's something there we can focus on, and maybe there's more than one thing to focus on. But I think probably, like I said, there's a kernel that we can start with, and just focusing it down to like some implementation. Yeah.
So, just one thing I wanted to ask. So, should I just start with this first idea, like you mentioned that development, maturation, and differencing that out, and just starting with some implementation of it?
Yeah, so get a good idea conceptually of how you want to approach that, and then you can implement it in Python if you want, just a demo, and then we can review the demo and see how it works, see what the performance
Okay.
looks like, and then refine it because you can't really start unless you have a good base.
Yes.
All right. Yeah. Thank you.
No, thank you so much.
Yeah. So I'm going to present on a. This is, of course, we had this discussion earlier. Jesse brought up some of the things about cognitive science and some of the discussions we've had in the cognitive science reading group. This is a paper. I think it's from a book. I'm not quite sure. This is The Challenge of Cognitive Science, and it kind of talks about cognitive science as an interdisciplinary endeavor, the contrast between psychology and neuroscience, and then the challenge of cognitive science. So we've read a number of papers in which cognitive science is defined, and then the history of cognitive science is defined as sort of the quest towards that definition. One of the problems of cognitive science is because it uses so many different tools and techniques, it stretches over so many input disciplines, is that it's hard to really kind of get a good sort of distilled sense of what cognitive science is. So it's an area of inquiry, but there's so much going on that's so diverse that it's hard to kind of, if you were to boil it down to a couple of important studies, how are those studies connected? It's very hard to see the sort of the pattern there. And then furthermore, like we've said, over time, there's been this sort of evolution in cognitive science from basic decision making to, psychophysics to AI and large language models and things like that. So there is this space of cognitive science, but how much is any one approach providing at any given time? So, of course, we start with the hexagonal diagram, and this was something that came from a 1978 report on the state of the art in cognitive science that was commissioned by the Sloan Foundation. So that's where we reference this cognitive science hexagon, and it's just a shape that describes sort of the space in between 6 input disciplines. And you'll see different disciplines, actually, if you look up the cognitive science pyramid on, if you Google it or something and you look up the different references, they sometimes have different names for the disciplines that are contributing. which is it's kind of slippery in that sense. So it's kind of hard to define this triangle or this hexagon or even any triangle within the hexagon properly, because if you're not using the precise terms, then it's a different field. So we have philosophy, which is a huge territory of things. I think largely in the philosophy that's contributing to cognitive science is largely philosophy of mind, although there are other parts of philosophy that can contribute as well. There's linguistics. So our focus on large language models isn't just kind of without precedent. There've always been linguists in the cognitive science enterprise, and the LLMs are the latest sort of version of that. There's anthropology, which in some ways contributes to cognitive science. A lot of the cognition in the wild work, and a lot of the situated cognition work is based in, at least in part, in anthropology. There's also thinking about human evolution and the evolution of cognition as well. There's neuroscience, of course. Again, these are all very large fields, so some parts contribute. And but it's, I guess, the spirit of the field that's really what when they came up with this hexagon is what they were thinking. So there's neuroscience, which of course is where we're thinking about neural circuits, and comparative cognition, but also sort of these broader questions of function. Then there's artificial intelligence. Sometimes you'll see computer science as this point in the hexagon. Artificial intelligence being the classical symbol manipulation artificial intelligence. But I think that still kind of fits in there as an area. And then psychology, cognitive psychology, which a lot of times people will conflate cognitive psychology with cognitive science. And of course, they're not the same thing. Now, within this hexagon, you have these triangles. So you have like a triangle between psychology, linguistics, and anthropology, or psychology, linguistics, and neuroscience, or artificial intelligence, philosophy, and anthropology. So you could recombine these in different ways depending on the question you're asking. So this is a very interdisciplinary field, and it's when they came up with the hexagon, they describe cognitive science as an amalgamation of all these fields. And I don't really think the amalgamation aspect is quite correct. It's more like maybe it's inspired by different fields. So depending on the question you're asking, you're maybe drawing from those different fields, knowledge and tools and things like that. So that's kind of what I think we're kind of going with respect to cognitive science. Now you can imagine that when you have so many influences that sometimes the field is incoherent, and that led to papers like Whatever Happened to Cognitive Science that we've talked about a lot, and just kind of people wondering what the state of the field is. So this is just kind of thinking about this in different, in this way. Some of the connections identified in the cognitive science hexagon were judged stronger than others. So we have dotted lines and solid lines. The solid lines are the more solid connections. The dotted lines are the more ephemeral connections. But nevertheless, these are all connections to be made. So it kind of, gives you an idea of where the bulk of the work is and where maybe lesser work is happening. This is kind of an interesting point. Some of the connections that were judged weak in 1978 has now become a thriving subdiscipline in its own right. Some philosophers, impressed by the potential for fruitful dialogue between philosophy and neuroscience, have taken to calling themselves neurophilosophers. So this started with Patricia Churchland's work in 1986 and has moved forward in a lot of the stuff that people have done on the philosophy of mind. So there's been a lot of work on, what was the book that It's Reality Plus. That was a philosophical take on virtual reality and sort of a lot of the cognitive science issues in that area.
I think, is that the one that Hussein did a review of a long time
Yeah,
ago?
Hussein did a review on that.
It's like by Chalmers, I think, or something.
Yeah, Chalmers. So again, this is, if you have a cognitive science talk series, you will get talks like that, and then you'll get talks on, using fMRI for human categorization, and then you might get a talk on comparative cognition between humans and, like other mammals or other animals. And, so it's a very diverse area. And the idea is that you should be able to extract sort of the commonalities between all these approaches. And so, okay, so this is a nice anecdotal story. Miller's account of how the Sloan report was written is both disarming and telling. The committee met once in Kansas City. It quickly became apparent that everyone knew his own field and has heard of 2 or 3 interesting findings in other fields. After hours of discussion, experts in discipline X were unwilling to make any judgments about discipline Y, and so forth. In the end, they did what they were competent to do. Each summarized his or her own field, and the editors of the volume patched together a report. This may be how reports get written, but it's not a very good model for an interdisciplinary enterprise such as cognitive science. So what he's saying is that they came up with this hexagon quite simply by asking people, what is your field? How do you think that they connect? And then kind of putting that all together. I would have thought it maybe would have been validated by a literature, mining exercise, but apparently not. So who knows?
It's kind of funny how much and this is like the major thesis of like a lot of the stuff. Like, why am I making? I'm sorry to just tangent this so much, but like, what's motivating me so much in many of the things that I'm doing right now is like that's. Thank you for the paper, Bradley, or the book chapter, because this is exactly in the service of like so many things that are the way they are right now are kind of exist in the context of I'm gonna very briefly share this, but like this is a broader concept of this is 20th century dreams or whatever, and this is a bit of a social commentary on it. But the same's true for like the DSM, like how these things, like all these things, why I'm doing what I'm calling like person studies or agentic studies, or I'm trying to come up with a new term for this cross whatever, cross domain looking at some aspects of science, what we call cognitive science, cognition, phenomenology, whatnot, is like, where does it come from? Well, a lot of like the bedrock foundations and demarcations of things are literally just, well, hey, here's like an arrangement of some stuff that's how when we first made it, we put the structural logic of the thing together in this particular configuration, and we just built on it because it's something to do. And I don't begrudge it, as this is like it's a very common soapbox for me. I don't begrudge that it happened. That's like when you're building something, when you're building new ground, just like we said about the Van Gelder paper earlier. I said the sympathy of Van Gelder making a somewhat contrived argument that he knew would be corrected upon later. Like, that's a great thing to do and a difficult thing to do, especially when you know you could be perfect. You have to start somewhere. So immense sympathy for that. Like, I'm not trying to shame, how stupid the people were who made cognitive science. So you have to start there. But the thing is, like, I feel like we're in this era right now where it's so vital that we really investigate the original structural configuration of the field and everything else versus not having to be beholden to the legacy configuration forever. And I think there's so much tension there, and there's new things emerging, but it's also like, you know, where's the path dependency of it all taking place? So we can go back to this, but like I appreciate you bringing it up, and I've had my little my tantrum about it. But I think articulating these, a lot of the work I'm trying to do in the Future Center in many ways is articulate ways of looking philosophy, history of science, meta-science, sure, where these domains developed and why they did or didn't go in a direction. I know we have that in Cognition Futures. I know it's a major part of reimagining cybernetics or reconstructing cybernetics as sort of our in-house Orel initiative. But there's just so much there, and I think this will be a good another tally on that board.
Yeah. So, in light of what you're saying, then the next part of this paper is, in fact, the hexagon as a whole is not a very good model for cognitive science. So this is kind of the take home here is that, we have this model that everyone cites, and then they wonder what happened to cognitive science, but in fact, it maybe isn't a good descriptive model after all. Even if we take seriously the lines that mark connections between the disciplines of cognitive science, the hexagon gives no sense of a unified intellectual enterprise. It gives no sense, that is, of something that is more of a composite of traditional disciplines such as philosophy and psychology. There are many different schools of philosophy, many different specializations within psychology, but there are certain things that bind together philosophers as a group and psychologists as a group, irrespective of their school and specialization. And so one of the main claims of this textbook is that cognitive science is indeed a unified enterprise, that it has its own distinctive problems, techniques, and explanatory frameworks. And so what we need isn't necessarily a hexagon, but to figure out what's going inside this hexagon, irrespective of the different contributing fields. So there are a lot of contributing fields in cognitive science. I mean, if you think about like the earliest artificial intelligence research, you had people who were interested in psychology, but also interested in computer science, which actually at the time wasn't really a unified field. It was just like a department at a university that grew out of the math department where they did things on computers. And they were developing sort of their own methodologies. But you'd use those then to move to some, work in trying to program machines that learned, like you might see in a psychology experiment. There's a story about how, so there was a department at the University of Michigan that was founded by John Holland, and it was the precursor to the modern complexity program at U of M. And there's a story about how John Holland was kind of in this space. He was like interested in psychology, interested in computer science, and wanted to bring them together into a program that people could, learn how to do things. And it was kind of like an adaptive computing, adaptive behavior type idea, but it was very fluid. And so it had influences and it would have eventually its own questions. But it was like, how do we sort of set this apart from all the other things going on at the university? And that's true of a lot of things that are kind of emerging and how programs form and how they have to justify themselves within the university. As Jesse said, there's this inertial aspect where you have to report to institutions and want to keep doing things a certain way, but also want to see kind of how things fit into their prior framework for doing things. And so this is kind of, the problem with cognitive science, right? What is defining cognitive science? And so this is where they kind of get into some of the things about that make cognitive science unique. There's, of course, the levels of explanation. So the levels of explanation in cognitive science are different than neuroscience, but actually different than psychology as well, because most cognitive scientists will place the study of the brain firmly at the heart of cognitive science, but it's not at the level of neuroscience. Cognitive scientists, by and large, don't care about, say, molecular mechanisms in the brain. They don't think in terms of circuits so much. They do think in terms of what happens in the brain, then linking that to the sort of these cognitive mechanisms or behaviors. Whereas psychology doesn't necessarily think about mechanisms, although depending on where you are in a psychology department, you think about that more or less. So, again, part of this is in that cognitive science has its own unique take on, what you're investigating. But then again, you go to a psychology department and you can find someone who's very much aligned with the cognitive science program and not really be a cognitive scientist or more of a cognitive psychologist. So it's very much, that's one of the problems, is that it's very much like, it's so broad that it's kind of bringing in things that sometimes do belong to other fields or that are concurrent with other fields. So this just shows the levels of explanation where you have, people are interested in what happens from neurons to pathways to cognition. And then this is a nice figure. This is, I think I've shown this figure before. This shows different modes of investigation for the temporal length of some phenomena of the brain versus the size of its phenomena. So like if you're looking at a synapse versus the whole brain, that's a difference in terms of size in millimeters. Or if you're looking at something that happens at a millisecond versus a day, there's this difference in time in terms of seconds. And all these, this is just a list of these different methods that are used to measure those time scales and those length scales. So like patch clamp is something you use on a neuron to measure electrical activity. And that happens at a certain time scale that's very different from, say, like lesion studies or fMRI. And then you could make this kind of graph, in fact, for a lot of things, not just for methods for measuring activity, but also for behaviors. And I think we have in one of our papers a map where we have like a time scale for different aspects of cognition. Yeah.
That's what I was thinking of when I saw this, and I couldn't remember which one it was. So I was also gonna say, like, definitely, if you can put this paper in this chapter in a Slack, I definitely want to, because this is a nice introduction for like some other folks that are kind of coming into some of the Cognition Futures stuff. This is, it's a nice, like, I'm glad we're getting like the methodology. Like this is sort of the methodology of the Cognition Futures method project stuff. So yeah.
Yeah. And then, of course, there's this challenge of cognitive science. There the three dimensions of variation. So one dimension of variation is illustrated by the subfields of neuroscience. Neuroscience studies the brain at many different levels. And in neuroscience, they adopt the vertical hierarchy of biology. So you go from neurons to brains to societies, and you can look at all those things in neuroscience. And of course, so that's something that cognitive science kind of adopts to some extent. Then the second dimension of variation comes from the different techniques and tools, which we saw in that figure, that are used at different time and length scales. And of course, the third dimension of variation is exemplified by the different subfields of psychology. So we might want to go out and explore, map, and describe and explain the cognitive abilities, making it possible to myriad things that human beings do and say. So, you have in psychology, you have different subfields like developmental, clinical, cognitive, psychiatry, all these different areas of psychology. and people are just interested in largely in the same thing. They're just interested in different ways of looking at it. So and then that, of course, is something, all things that we can adopt into cognitive science. And then they have this figure here, which is the space of cognitive science. This graph is not as informative as I would have liked it to be, but basically it kind of shows these different modes of inquiry: vision, memory, language, problem solving, and then these other things that are not specified. And then that's the x-axis. The y-axis are the different methods for getting at these things. So like fMRI, behavioral data, and some neurophysiological recordings down here. And then, of course, you have the levels of organization: molecules, synapses, neurons, networks, the central nervous system on the z-axis. So it's this three-dimensional plot: investigative technique, levels of organization, and domains of cognition. And then the idea is you could plot out your study or your area of interest as a space or as a dot in this space. And that defines your interest in cognitive science, I guess. So it's just kind of breaking ourselves out of that hexagon and thinking in different ways about how to define cognitive science. So it's good stuff. And then this is just as the preface to a book, and this goes through, and I think this stops here at the prehistory of cognitive science, which is another story for another day.
So what was is it a history of landmarks? What was like that was one of the titles or something?
History of landmarks?
Like scroll up. It was like that. Historical.
Oh, this is just where they're going to go through the history of cognitive science.
Okay.
Then there's this prehistory, which is like going back to behaviorism and psychology and the reaction against that, and then the rise of computationalism. And so those two things kind of came together.
And that's like, it's so interesting. It's very interesting to see. Okay. Part of the rant, and also, hi, Aaron, glad you're here.
Hi, Aaron.
Join us. Said some comments about black holes and whatnot in the chat. Part of my continuous ranting about all of this stuff is it's so interesting now, and I feel like I know I've kind of happened into a space where I regularly am in contact with clinical social workers, clinical psychologists, people that are wielding kind of the fruits of what we're supposed to be examining in the applied sense, people purely in the theoretical sense, philosophers. And I guess I feel like it's a little bit bizarre to me that I don't think I should be such an I know that many people are interdisciplinary and do things in multidisciplinary ways. I'm not special about that. But it sort of is a bit baffling to me on many fronts that there's not really a little more concerted effort, even I would even say at a popular phrasing now is like epistemic honesty, or like ontological and epistemological humilities about things. Like yeah. But I think there's so much integrative work to be done, let's say. I'm just going to kind of gesture towards what all that means and everything else I've been ranting on about. To kind of come back to what we were saying, yes, this is a nice introduction. Things like very textbook and getting at things in a nice way. So we can look at that and something to bring about into, Cognition Futures and some of the new folks in the program. The last thing I'll say about this, and I don't know how much more time we have. Oh, not much, I'm sure. I think, I forget if you brought this up, Bradley, or this is something that's come from some of the other things, but just how there's a conversation a few weeks ago, it might have been one that I initiated or not, on sort of cognitive science 1.0, the hexagon, and also this sort of, at the time, the bracketing of, we're really going to center computation, we're really going to center computational modeling, the idea of computation. It's hexagonal, but I feel like the real there should be something in the middle that's not there in the hexagonal classic cognitive science, which is like computation. Like computation was supposed to be not necessarily the golden ring of it all, but the one ring of it all. But like it was supposed to be, you were supposed to be the chosen one. Like you were supposed to be this thing that was going to do all this stuff, and not that it did or didn't in a particular way, but just it kind of became a gesturing tool or a reference point. And then the two quick things I want to say is, it was really informative one time when I went to, ironically, in when I was considering doing a PhD in cognitive science, I went to the UC San Diego, which is one of the first ever like very large, broad, interdisciplinary cognitive science programs as a institution. Like they made it very much on purpose at the time, which and I think the university itself was 1960 or so. So it was kind of in the right moment for a lot of these things. Fantastic people there doing fantastic things. But it was so interesting to go to this open house and to see the cognitive science people, or like the I think it might have been a psychology open house and not a cognitive science open house. I forget which. But just seeing the cognitive scientists and their mechanistic approach, and then social or developmental, and it was very interesting and informative at that level to see it at the time. And then the last thing I'll say is the bracketing component. I'm going to kind of step back. The bracketing component and computation relative to the 1943 paper and that step ladder, that diagram of trying to taxonomy diagram of breaking down the things, and how there's sort of a movement towards, okay, well, we're going to use computation to kind of, we're going to center it here and use computation to explore these human domains of it. And a lot of, I think, Levin's work and work that we might be concerned about, interested in, is sort of maybe bringing it back out again, where we're looking at where things are a bit more level and trying to do the original aim of the 43 paper, which was principles that would apply across substrates or embodiments, natural or artificial. So I think that sort of points to where we can go with some of the things, but I'll leave it at that. We're way over time. I don't know if you want to look on anything there, or Aaron's comments, but I know we have to go.
So. Welcome, Aaron. You did some pretty good, made some pretty good comments in the chat. So you brought up a paper on neuroplasticity, and and then Aaron says, I don't think our visual representation for modeling this should be a static polygon anyways. Yeah, it's like that was kind of the way that they conceptualized it. Of course, we mentioned that it wasn't really a very good model. And this is neuroplasticity, century-old idea championed by Adolf Meyer and Susan Lamb, and then just Meyer and occupational therapy, which was who Adolf Meyer was. And then, or is this, and then a pioneer 21st century American psychiatry. He was the psychiatrist in chief at Johns Hopkins Hospital and is best known for developing psychobiology. Yeah, yet another field. And then that's just kind of like, is that part of cognitive science or psychology or what?
Right. And like, also, like, to be very polemic for another moment, I know occupational therapists and clinical psychologists and whatever, and it's like, that was like, you put them in the same room and talk about, like, I always feel like I'm on like Return of the Macy's conferences for these kind of things, and it's like, I don't know, I'll leave it at that. But yes.
Yeah, the language, a lot of times it's just adopting your own language. That's the distinction. And it could work better if people use common language, like we talked
Right.
about with this
And that
Randall Beer paper.
exactly. I was gonna mention like the languages as lenses and letting it be. It's okay to have the language, but you also need to do translations at times. Um,
Yeah.
I'll follow up to Kavya at the end, but if you can go through, I think we're pretty much done. But
Yeah. And then Aaron had here I googled visual representation of accretion, and then black holes, and then black holes and rotating black holes please me a bit better as a working model, and then about event horizons, and so that's good. And then Kavya had this comment. I just wanted to say that, as Jesse mentioned earlier, some people might be interested. I'd be happy to connect and learn. So Kavya, definitely, if you found something Kavya was presenting on interesting, jump into that conversation and give your feedback on his document.
so what? Yeah, and to do that in 30 seconds, we'll try to clip this presentation, and we can make a little like paragraph or card, like some kind of a here's what I'm looking at, and we can talk about it here and in the Slack and in JavaPro as well. I'm creating sort of a project development task board, or like join up and help out, call for involvement type things. So
Yeah.
we can make something there, and there's people in that group and in this group that are looking for that to do. So we'll follow up in Slack about that. But yeah, this is a good broad meeting today, and thanks for taking the extra time to go through the stuff, Bradley. I'm sure you did that with my rants in mind, so thank you.
Yeah. All right. Thank you. Have a good week.
Bye, everybody.
Take care.
Thank you.